And good evening. Okay, cool. So let me just, we're gonna see how far we can get tonight. Um, we will focus on three topics that you guys need to be prepared for before your assignment that's due on Friday, I think. So we will last week we looked at numbers and variables and the basic operations. Um, Tonight we'll look at more operations on numbers. Topic 3, then we go into some measurements, and then expressions, equations, and formulas. What you will also see is I will share a presentation afterwards as well, so that you have all the, when we get to the measurement um, chapter, that you have all the formulas on the presentation, so it's just easier to get to. But then also we starting, I think let me just copy the link to the WhatsApp chat that I have for BNU, and then also if you want to send me a WhatsApp and you can't access the link, you can send it to 0837908387. Okay, so let us get underway. So the first thing under the more operations on numbers, so I think it's chapter 3 or topic 3. We're gonna look at all the factors. So we're gonna look at factors of a number, how we break that up into, so if we get a number, how to break it up into factors. Then we're gonna look at the lowest common multiple. So when we need to simplify, we need to look for the lowest common multiple. Then we do some basic operations with fractions and with decimals. And then we look at nearly another form of decimal or fraction, is percentages and ratios. So we will basically look at those four things for chapter 3. Then we go into measurements, and then we'll look at the last one. Okay, so when we go into fractions, so what I've given you here is just an example of a possible way of looking at factors, and there's other ways to look at it as well. So the next slide we look at some examples, and then I'll show you some other ways to break up the factors as well. So this is one way nearly to say, okay, but what goes into 120? So it's easy nearly to say, if we look at a 12 times a 10, that will give us 120. Then we can break up the 10. To break up the 12, we can say, well, 4 times 3 is one of those. But then again, we're sitting here with a 4 that can be broken up into two twos, basically. Another way that I normally love to do it, is I would just nearly write for me a diagram like this. So I will first say, okay, but I know 2 goes into 120. 2 goes into 120 60 times. Then I know, okay, well, there's another 2 that can go into 60. That is 50 times. Then, well, there's another 2 that actually goes into 30. So 2 goes into 30, and let's just make it on this side 15. Then I'm like, okay, we can't use 2 anymore, but let's see, 3 goes into 15 in 5 times, and then we can say, well, 5 goes into 5 once. Okay, so then what we're also sitting with is base with 2 to the power of 3 times 1 3 times 1 5. And you will see it's exactly the same as we have there. So again, you can decide which one is easiest for you. I'll give you always some examples and extras how I would work it out, but you can again decide how you want to work it out and what's the simplest way for you to get to a final answer. In the end, you will again have options A, B, C, and D. So you just need to get to those answers. So the method how you get there doesn't really matter as long as you get the right answer. So for me, if you look at the factors and how to calculate it, there's 2 ways. I like this way more because it feels like I don't need to know the bigger numbers. I can just start with the simpler numbers and then work through. Okay, so let's go through a few other examples. So what I've done is we've can look at how to factorize 21, 48, and 72. And again, for me, how I will always start is to say, as we've done with this one, okay, but what's the smallest number that can go into 21? Okay, that is 3. 3 goes into 21 7 times. Oh, okay, this is not a great one because it's basically all that can happen. So if we needed to factorize this one, it was 3 times 7. Okay, so probably will not get something like that unless I want to nearly see if I can catch you out, because again, I would have thought that is way too easy and maybe look for another way to do that. Okay, so that is if we factorize 21, but let's see if we factorize 48. So if we factorize 48, again, start with 2. 2 goes into 48 24 times. Then we need to say how many times does 2 goes into 24. That is 12 times. So then 2 goes into 12 again. That is 6 times. Okay, 2 goes into 6 again, 3 times, and then 3 goes into 3 once. Okay, so this was a bit, different. So the final answer here would be 2 to the power of 4 times 3. Okay, so when we factorize this one, we could have seen there's 4 2's, and you can always afterwards just check it. So 2 to the power of 4 is equal to 16. 16 times 3 does give you the 48. Okay, so let's do the last one, 72. So again, I start with 2. 2 goes into 72 36 times. 2 goes into 36. What's that? 18. 2 goes into 89. 3 goes into 3 times, 3 goes into 3 once. I will make this bigger again. So basically, now we sit with 2 to the power of 3 times 3 to the power of 2. Okay, so that is how we will factorize the numbers. Okay, any questions around that? Happy with that? It's the same principle even if we get a bigger, and I'm now just a bigger number. So say that is the number. We will again start with 2. So 2 goes into that 236. Then again, 2 goes into that 118. 2 goes into 118, 59. And then I think 59 is going to be a problem because 2 doesn't, 3 doesn't, 4 doesn't, 5 doesn't, 6 doesn't, 7 doesn't, 8, 9. So that is probably where it's going to end. You can check if there's anything else, but probably 59 is a prime number. So yeah, so it's not a great guess, but that would be the process that you follow. Sorry, let's just do that right. Okay, cool. So that is factorization. Then the next one is looking at the least common multiple. So basically what the least common multiple is when you're looking at a few numbers and you nearly need to decide what is the smallest number that you can get so that you can work with all of them. So if you look at 12, you see, okay, well, 4 and 3, but that is again 2 and 2. If you look at 15, well, the smallest is 4, 3. If you look at 20, 5, 4, 2, 2. Okay, so there's 2 2s there, there's 2 2s there, so you will have 2 of them. There's 1 3, there's 1 3, so you will have only 1 3 because it's there, and then there's 1 5 and 1 5. So in the end, the least common multiple for these 3 numbers would have been double 2, the 3s, and the 5. Okay, so that is how you would work out the least common multiple. So again, with that, we will get a few examples. So if we look at 9, 9 will be 3 times 3. If we look at 15, 15 will be 3 times 5. Again, nothing else that we can do there. If we look at 30, well, 30 is 2 because 2 goes into there, then it's 15. So then it is, okay, so what would you then say is the least common multiple in this one, where we have 3 and 3, 3 and 5, 2, 3 and 5? and you can type it in the chat as well. Okay, so let's quickly check. Okay, so what I would have said is the 1, 2, then the 2 3s, and the 1, 5. Okay, so that would have been your lowest common multiple. Okay. So, again, depending on what your answer set is, they can also have it as a number. So they can also say, well, 2 times 3 times 3 times 5 is equal to 90. So again, let for answers basically determine how you would answer it, because if the answers is like 60, 70, 80, and 90, then you know you need to multiply it out. If it was still in the factors, then it's different. When you just look that everything is covered. Okay, so let's look at the next one. So 8 is 2 times 2 times 2. 32, sure. 2 times 2 times 2 is 8 times 2 is 16 times 2 is 32. So will that then be 2 times 2 times 2 times 2, so 5 of them times 3. Okay, so 2 times 2 times 2 times 2 times 2, that's 5 of them. There we have 5 as well, times 3. So then that will actually be your lowest common multiple, which would be 96. Are you guys happy with that? This was an interesting one. I thought the previous one was making a bit more sense. This one was a bit stranger, with the different numbers, but actually every time you just add 1 or 2 extra factors. So the final one is actually exactly what you would have wanted in any case. Okay, so that is lowest common multiple. Then we go into fractions. And yes, they in your study guides they talk about proper fractions, improper fractions, and mixed fractions. So again, please we normally want to simplify something to a mixed fraction, but again, if your answer set is for 8/6, keep it as 8/6. Don't then go to a mixed fraction unless they ask for it. So again, the question and for answers would really guide you what to do. Okay, so hopefully you don't get in your assignment things that you're not sure if you need to write it in an improper fraction or in a mixed fraction. But proper fraction basically is when it's only the fraction. Improper is when your numerator is bigger than your denominator, so the top one is bigger than your bottom one, and then your mixed fraction is when you have a whole number plus a bit of a fraction. Okay, so let's again look at things that we do with fractions. So first, there's ones that we need to multiply. Then there's also a few that they say, write the following improper fraction as a mixed fraction. So this one, let's do this one first, because that for me is, you should not be, then the answer set should not be confusing. It should be straightforward that from a 7/5, one can write it as 1 and 2/5. Okay, so that will be the improper moving into a mixed function or mixed fraction. How to test your answer again is to say, well, 5 times 1 gives me 5. 5 plus 2 is equal to 7. So that will give me the improper function again. Okay, so the same if we look at 13 divided by 7. 7 goes into 13 ones. What's left is 6/7. If we wanted to test it again, 7 times 1 is 7. 7 plus 6 is 13. Okay, and then the last one that we're working with is 22/6. You can use your calculator, so you can say 22 divided by 6. That will give you 3. Then you can say, well, 3 times 6 is 18. So what is left? 4. Okay, so now the question is, do we simplify that further so that it is 3 and 2/3? So again, check what the answer set will be, because that we could have rewritten as 11/3. So just check what the answer set is. If you need to, you probably need to simplify more. So that is probably going to be your final answer. But still, if that's not there, but 4/6 is, you take that one. Okay. So that is just moving from improper function or fraction, sorry, to a mixed fraction. The other thing that they can ask you is give you a few fractions, and then you need to multiply it out or add them or divide or subtract. So we've got here a few fractions, but the first thing I normally want to do when I look at this is to simplify first. So I look at the 5 and the 45, and I'm like, okay, 5 goes into 5 once. 5 goes into 54 9 times. Then I'm looking at, okay, so let's see what goes into 39. I think 13 goes into 39. Yes, so 13 goes into 13 once. 13 goes into 39 three times. Okay, so there's at least some form of simplification. So we now know that that is totally gone, so it's not part of the equation anymore. Here we can say, well, okay, 3 goes into 3 once, 3 goes into 9 three times. So at least we sit with a much simpler formula that we can then work out. So 7 times 1 is 7, 16 times 3 is 48. So then the last question is, can 48 go into 7? No, it can't. So then that is our final answer. Okay, so a bit of simplification before we nearly get to the last things that we multiply out, just to make it a bit easier for you, and because I also don't like to work with the bigger numbers, and then if we need to simplify, it becomes difficult to simplify with big numbers. Okay, so the same thing with simplification we can now have in a function that has variables in it as well. So I think that's also important that that we do the variable one as well. So let's just look at, again, first, as always, I want to simplify. So it's a bit more difficult with this one, but let's see. Okay, 4 goes into 4 once, 4 goes into 36 9 times. Okay, so that is at least a bit smaller. 7 goes into 7 once, 7 goes into 35 5 times. Then we can probably say 2 goes into there 5, 2 goes into there 7 times. Okay, so at least a bit better. So if we multiply those ones just out, we've got 25 at the top. 7 times 9 is 63. I don't think we can simplify that out any further, but let's see with the x's and y's what we have there. So x3, so we will add it, so there's x4 at the top. So that is gone, and then we sit with a y2, and at the bottom y1 plus y1 is equal to y2 and x2. Okay, so then one can see that and that will cancel out. There's 2 there, so we will take 2 away. But we will then need to take 2 away at the top as well. So at the top we have 25 x to the power of 2 divided by 63. Okay, so that is a way to simplify when we work with fractions that has variables in it as well. I just want to take that away, so when I send it on that you guys can see it. I will also share the video, so don't worry that it now seems that it's disappeared. I will share the video with you as well, so that you can go through it. Okay, so that was basically simplification with a fraction. The top one didn't have variables in it. The bottom one had variables. So that is nearly looking at the fractions component. Then what we also have is decimals. So What you will also see is that they can, and I don't know if I've added it, but then we will quickly do one. I'll just show it to you. Uh, so the one is simple to say, but write the fraction into a decimal. The other thing that they can also ask you is to round it up um, to the next decimal or to a certain decimal point. So let's first do the decimal component, and then let's see afterwards if there's one that we can use as an example to round off. So you can again use your calculator in this instance. So 2 over 5 will be 0.4. So that is a decimal. Here, what can one do is to isolate the 2 first. So it will be 2 point something. So we need to look at what is 1 divided by 6. So 1 divided by 6 is, and now that is where it will be, and if I don't show it in any of your textbooks, it will be 2.16, and that dot above the 6 means that it is continuously 6, 6, 6, 6, 6, 6. So you can basically put a dot on a number, and that represents that it is continuously going with that same number. Okay, so now they could have said, okay, but round this off to the nearest third decimal. Okay, so then we will need to look at, okay, what if we need to round it off to the nearest third decimal? We need to look at this number and decide, okay, if it's 5 or bigger, the 6 will become a 7. If it is less than 5, the 6 will stay the same. So it's bigger. So if we round it off to 3 decimals, our answer will look like this, 2.167. You can also, on your calculators, if you have, you can change your calculator that it only looks at 3 decimals. If you have Excel and you also want to quickly do that, you can on Excel exactly do the same. We just quickly want to increase that. So if you said it was 2 plus 1 divided by 6, you can see, so if I want to round it off to 3 decimals, it will be 2.167 like we got. So you can just with that one play around to see, okay, if we needed to round it off to 2 decimals, 2.17. If it's 1 decimal, 2.2. If we need to round it off to with no decimals, it is 2. So again, you can decide, then much easier also in Excel to just look at how you can round it off and not. Then the last one, 7 divided by 8. So 7 divided by 8 will be equal to 0.875. And again, if we need to round it off to 2 decimals, it will become 0.88. If we needed to round it off to 1 decimal, it will become 0.9. And if we rounded it off to the first whole number, it would have been 1. So again, depending on how they want to see it, and how they ask the question with how many decimals, because that's probably what they will do, you can see how it can change accordingly. Okay, so that is nearly how they will look at the decimals. and how you need to round it off. Then we go into percentages. So again, we'll take a fraction and put it in a percentage. So they can ask it nearly two ways. So they can ask you, okay, you have 6 out of 15 for your assignment. So 6 out of 15. Um, how much is that as a percentage? So you can just then say 6 divided by 15 times 100, which will give you 40%. Okay, so the important thing with percentages is that you multiply the fraction by 100 to put it into a percentage. How I normally look at it again is, so if you look at that, I normally say it's 1, 0, 0. So you can really see there's 100 that is forming out of that. So that's just for me the easiest always to say, well, I need to multiply my fraction with 100. Okay, the other thing that they can ask you is to say, well, you have something, you buy something, you pay something, and you get a discount on it. Or the other way around, they can say, well, you buy something and you pay a tax on it. So you need to add the percentage to it. So in this instance, they said, okay, but you get a discount of 25%, and determine the amount of a discount. So again, how we would do that is, so the 5,500, and we will just multiply that by 25% to see what the amount of a discount is. So they just want the amount of a discount. So 5,500 times 25% gives you 1,375. So that is the discount that you're getting. So they could have asked a follow-up question. So if that is the discount that you're getting, what is the final amount that you're going to pay? Then it is just the 5,500 minus the 1,375, and that will be the final amount that you will be paying after you received the discount. So that will be 4,125. They can also ask you something like that 5,500, you need to pay tax on that. Tax is 15%. So if you pay tax on it, what will the tax amount be? So that is 5,500 times 15% gives you 825. And then they can ask you, okay, but what's the final answer? How much will you pay in the end? In this instance, since it's a tax, we will add it and not subtract it. And then your final answer will look like 6,325. Okay, so they can give you a discount that you need to work out. They can also ask you to work out a tax amount, and then they can ask you to nearly get the final answer of payment for that amount. Okay, so let's look at what is left. The other thing that they can do is to say, well, if you get a percentage, put it into a fraction. Again, if I look at, say, something like 18, so if it was 18%, and we write it as 18 over 100, just check again what the answers is, because it might be that there's a 9/50 because that was simplified. So it might be that they also give you the simplified answer in your answer set. So just be, again, careful. With percentages, I hope they stay at the 18 divided by 100, because that is how we read percentages. But it might be that they have simplified, but then just make sure you know how to simplify it. Okay. Okay, so that is nearly looking at the factors we did. We did the lowest common multiple. We did fractions and decimals. We did percentages. Now the last one in this batch is ratios. Okay, so ratio is also nearly a fraction. So again, depending on what they ask. So if you look at the value of the ratio AB, you can write it also. And what I normally change is, if I see something like that, I do that, and then it's nearly, you can see it's A divided by B. So basically, from a ratio, you go again into a fraction. So they can once again ask you to write the fraction. They can ask you to write the fraction as the ratio as a fraction. They can also ask you to simplify it. What they can also ask it is the other way around. So they can give you a fraction and ask you to write it in a ratio as well. Okay, so that is nearly what they can do. So they will seldom, I don't want to say seldom, but most likely is that it's a simplified fraction and the simplified ratio that you will work with. Most likely not going to ask you to increase it. Okay, so let's look at examples of that, and how again they love to ask these things is, especially fractions and percentages. They like to ask, sorry, not fractions, ratios. And percentages, they like to ask, word sum. It's seldom that, and you could have seen here as well, it's seldom for these that they're just going to ask you to rewrite 18% into a fraction. So the same, not really going to ask you to rewrite a fraction into a ratio or ratio into a fraction. They can, but not likely. So let's see how when we get a word sum, there are 15 green apples, there are 25 red apples. Determine the ratio of green apples to red apples. Okay, so green apples to red apples is 15 to 25. Okay, again, if you look at your answers, you could have simplified it, but it is 3 to 5. Be careful with these questions, because what they like to do a lot is, here they say green apples, red apples. Then when they ask you a ratio, they ask it the other way around, and they ask, determine the ratio of red to green apples. Okay, so they can do that as well, and they normally love to throw it the other way around. But then red to green, you do exactly the same. You say, okay, well, red apples is 25, green is 15, so there's 5 reds to every 3 green. If you've read it this way around, there's 3 greens to every 5, so that and that is exactly the same. It's just out of what way you're looking at it. So just be very careful, specifically with the ratios, that they don't throw in one of these weird ones that they ask you just the other way around. Okay. Okay, so let's look at the next one. So here they say Jacob's decide to divide his flock of sheep. So he's got 57,000 amongst his 3 sons, Tabo, Lucas, and Sipho, and they get it in the ratio of 3, 11, 5. Okay, so let's just Tabo, Lucas, Sipho, they get it in the ratio 11, 3, 11, and 5. Okay, so the first thing that we will do is to say, okay, but if we add all of them together, let's just get the total size of the ratio. So it's 3 times 3 plus 11 plus 5. So that looks like 19. That's 57,000 go into 19 3,000 times. Okay, so if we say 57,000 divided by 19, we get 3,000. So we know for each one number, it should be 3,000 sheep. So for 3 numbers, it will be 9,000. For 11, it will be 33, because we just multiply the 11 by 30 by 3,000. And then the 5 times 3,000 will be 15. And hopefully when we add it up again, we will get 57. So let's see, 9,000 plus 53,000 plus 15,000 is equal to 57. And then the final thing that they've asked is determine how many sheep Lucas will receive. So Lucas is the one that receives the most. So Lucas will receive the 33,000 sheep. Okay, so that is when we look at ratios. We basically look at differences of, they can tell you, they could have said in this one, you've got 40 apples, and you need to split it according to the ratio 3 to 5. Okay, so then would have gotten the very similar answer of 15 to 25. So there's nearly 2 ways that they can ask, or would likely be to ask, the ratio questions. Okay, so that is study unit 3 that we've done. So let's go into measurements, and what is important nearly on the measurement side is we're gonna do that. We need to calculate the length. We're gonna do a part that we need to calculate the area, and we will do one where we need to calculate volume. So that will be nearly the 3 things that you guys need to be able to do. So yes, they tell us convert length units from one unit to another. So that is nearly where we need to convert a millimeter to a meter or something like that. The perimeter is basically if I need to determine the perimeter of this block, I would have just added all the sides, the lengths of all the sides, and that's how one would get the perimeter. Then determine the area. We're going to look at that because depending on the different types of figures, the formulas are a bit different. And then we will also look at determining the volume. Then just a few ways to nearly look at converting liters to cubic units or cubic units into liters. And in the final piece, nearly getting a weird figure and you need to solve it. So I will already, you can see in one of these slides, nearly I've done something like that already, but we will need to calculate that. Okay, so converting units. So here is some what you can, again, when I send the presentation on tonight, you have it, so you can really look at ways to convert. So if we convert millimeters to centimeters, where you can see 1 centimeter is 10 millimeters. So basically 150 millimeters to centimeters will just be 15 centimeters. So we will just take one of the zeros. So we will end up with 15 centimeters. Okay, so one can use this very nicely. You don't really need to worry about the decimeter, and you probably also don't really need to worry about the hectometer. So it's more about millimeters, centimeters, meters, and kilometers that you will need to think about. But the other measures are here just if needed as well. Just to make sure that they don't caught us off guard. Okay, so 150 centimeters to meters. So you can look at meters. So 100 centimeters will be 1 meter. So 150 centimeters will be 1.5 meters. Okay, so another way of looking at it, so the 150 millimeters to centimeters, we could have divided by 10. If we go from centimeters to meters, we divide by 100. Okay, so now going from meters to kilometers, we divide by 1,000. So that would then be 26 kilometers. So 26,000 meters is equal to 26 kilometers. Then to go from meters to centimeter, well, if we divide it by 100 to go from centimeter to meter, instead of divide, we will need to multiply. So to go from meter to centimeter, we just say 6,5 times 100, and that will give us 650 centimeters. So 650 centimeters is equal to 6,5 meters. Okay, so that is nearly just a quick way of converting. Doesn't matter if you're converting up or converting down. Some ways of doing that with a nice example also in this slide. Okay, then the next thing around length and um, basically what we're looking at is perimeter. So for perimeter, what we will need to calculate, yes, an example, we'll get to that now, but for all your other areas that you guys can have, a triangle, the perimeter of a triangle will be just the three sides that you will add together. If you look at the square, it will just, you can say 4 times one of the sides, or you can just add all 4 of the sides together. Rectangle, basically length times breadth, and then you can say times 2 because there's 2 more, or you could have just said if that is 5, that is 4, well, that must be 5, that must be 4, and add all of them together. Then if you go into a pentagon or hexagon or whatever gon there is, all that you need to know is that doesn't matter how many sides. So if there was now 6 sides, all those sides are always the same length. So for this one, there's 5 sides, so you can say 5 times one of the sides. If it was 6, you just say 6 times. If it was 7, 8, 9. So every time you add another side to it, remember the sides are always still similar. So if it was 8 sides, just say 8 times what one of the sides was. And then the last one is the circle. And the circle, I think what is important, it's really not like the others. So they need to give you the radius of a circle. What they can also do is give you the whole length of that. So then remember that the radius is half of that length. Okay, so to work out the perimeter of a circle, it's 2 pi times that radius. So also, what is it, 22 over 7, I think, times the radius. Okay, so if pi is not on your calculator, just remember it is 22 divided by 7. Okay, so that is just looking at the formulas. So what I thought, okay, let's throw in a weird one. But just to again make it clear with perimeter, all that we need to do is add all the sides. So what we're going to do is just to say, well, okay, 9 plus 12 plus 19. So that already is 21. Up until there is 40. Then we're going to say, well, plus 17. That is 57 plus 25. So 57 plus 25 is 82. 82 plus 22 is 104. 104 plus 50 is 154, and then we add the last 50 to it to get 184. So the perimeter of this was 184. Okay. The interesting thing, and just again, please just check that somewhere they don't want to catch you out again. So what they could have done with this is also to say, instead of a 19, they give you, sorry, instead of a 19, they can tell you, oh, but that is 190 millimeters. Okay, so please, when they give you these sums, just check that all of your units are in the same unit nearly. So that you don't now go and say 9 plus 12 plus 190 plus 70 plus 17 plus 25, because then you will get a different answer. So just again, be careful when they do these things that the units are similar. If it's not, just convert the unit to what most of the other units are. So if there was only one that is millimeters, convert it into centimeter and then work out the rest of the question. So just be careful, especially with perimeter, volumes, and areas, that whatever they give you, that you look at it and make sure that it is the same units. Okay, so that is perimeter. The next one that we will go into is area. So again, if you look at area, just what I added here is a few different shapes that you guys might come across. So the circle, I added the triangle, the square, the rectangle. I don't know if you guys do the parallelogram or trapezium, so I just thought, let's add it. Then you have it. Then they can't catch you out. So that you can also just see what the formulas is. So when you get an example like that in your assignment or in the exam, you at least have the area formula. Okay, so in this instance, this is probably something that they would love to ask, because here they test uh, a circle or half of a circle. Here they test that you can get the area of a rectangle, and here they test that you can work out what the area of a triangle is. Okay, so let's do the circle first, or the half circle. So if a circle's area is pi r square, a half circle will just be divided by 2. Okay, so let's just first get all my formulas right for this. Here we've got a rectangle, so all that we need to do here is to say length times breadth. And then here we've got a triangle. Triangle is half base times height. Okay, so that is the triangle. So that's one sum, that's another sum, and that is another sum. So three calculations, and then we need to add all of them together. Okay, so let's see. Pi is 22 divided by 7. Radius, do we know what that radius is? would you set is that radius? You can also type in the chat, what do you think that radius would be? Because I want to show you something else that they could have done. But please type a radius, and I want to show you something else. Okay, so the radius is basically the half of that length. We know that length is 14, so the radius is 7. Okay, so radius is 7. What they could have done is they didn't need to give you this. So they could have excluded that, and they could have done this, and just drawn that and say that is 7. Okay, so that, because if that is 7, that's also the radius. Then that must be 7. And if that is 7, then that whole line will be 14. So they could have not given you that 14 and just indicated there, so that you nearly need to remember, okay, but there's that is radius, so that is radius, so so that I can get the total length of that line. So just if something at a point looks weird in one of the sketches that you guys get in the assignment on the exam, just make sure it wasn't because about the radius, and it might then be that you can use that to calculate something else. Okay, so we've got the area for that. Length times breadth, that is straightforward. That is 14 times 25. So that will get us this area. And then a half base. So a half base is half times 14 times the height, which is 10. Okay, so that gives us the triangle, it gives us the rectangle, and it gives us the half of a circle. And then we just add all of those together. So half times 14 is 7, so that will be 70, plus 14 times 25, which is 350, plus, so again, use 22 divided by 7 times 7 times 7 divided by 2 gives you 77. So that final answer will be 77 plus 350 plus 70, which will give us 497. Okay, so in one question, we nearly have answered how to work out 3 of the areas. They they might now in your instances also do a bit weird things. Okay, I don't know why I added that. Let me just delete. They might also do something where you have, say, a square or rectangle, and then they say, but there's a circle within it, and you only need to calculate the piece without the circle. So then you calculate the square and you subtract the circle in the middle. So they might ask things like that as well. But if you then follow the same principle, they need to give you at least something in here that you can work with, so that you can work out the area of a circle, but you can work out also the area of a square. Okay, does that make sense? Does it help a bit? Um, I hope it's a bit clearer for all the things that you guys need to complete for Friday. Okay, so sorry, from perimeter to area, then the last one that we add is volume. So if you look at volume, the thing that, and I see some of these are not too clear. So volume of a square is sides to the power of 3. Volume of a rectangle is width plus height plus length. So that is just the 3 sides. If you do look at a sphere, that is how that would look. So that is the formula for that is a third pi r squared times height. So they need to give you that height in there as well. If it is a ball that you need to work out, it is 4/3 pi r to the power of 3. You don't know why that is a formula. You just use it. If you have something like this, again, at the bottom, you have pi r square, which is just the area normally of that. And what you add then is your height. So that's that formula. And for, I think this is called the prism, you have the one side, which is your triangle, which is half times base times height. So that would have calculated that side, and then you just multiply by the total height of that. So that is nearly the different formulas that you guys can have for this. And again, I think this is probably a bit more than is in the book, but again, I just made sure that we nearly cover any possible thing that they can throw at you guys. Okay, so now using that, we're gonna do a few of these. So the first one is determine the volume of a rectangle prism. Okay, so that is a rectangular prism. So half base height times the bigger height. So half base times height times the bigger height. Because it's all multiplication, and we started off in the first nearly topic on multiplication and sequences of it, it doesn't matter which is which. So how we would just calculate is we can use whatever we want to. So I can use it straight as they tell us. Doesn't matter which way the numbers are. When you multiply it out, it doesn't matter the sequence of the numbers. So a half times 50 times, sorry, a half times 50 times 50 times 15, and that will give your answer. And I got it. That doesn't seem right. Let me just 0.5 times 50, 25 times 50, 750 times 15. Yes, I thought so. Is 11,000 and 11,250. Sure. Okay, so 11,250. And when it is cube. So if again I want you to look at different answers, look for the one, if there isn't one with cube, if I just give you numbers, then it's fine, but just make sure that else you select the one with the cubic sign with it. Okay, then, so that was the prism that might look something like that. Okay, so then determine the volume of a cube. So cube, we know that all the sides are equal. So all that we do with a cube is to say, okay, the volume is 35 to the power of 3. So 35 times 35 times 35. That will give us 42,875. And just remember, again, the meters cube. So that you always add that again to your answer. Okay, and then the last one seems a bit different. So determine the volume of a cylinder with radius of that and a height of that. So let's look. It's normally the more difficult one to draw. So height of 3.2 meters. That's high. And they tell us a radius there of 0.75. Okay, so in this instance, they gave us 0.75 meters. They could have said to us 750 centimeters. So just make sure that we have it in the right format. And then volume of a cylinder, if we go back to cylinder, is pi radius to the power of 2 times height. So pi radius 2 times height. So 22/7 times 0.75 to the power of 2 times 3.2. Okay, so that will be how we work out for the volume. 22 divided by 7 times 0.75 times 0.75 times 3.2, and let's round it off to two decimals. So I get 5,66. And again, remember cubic meters. Okay, so that is how we would have solved questions around volume. They will not really do this for you in volume. Let's be honest, they will not do that. So your volume will be a straightforward solve the volume. And then it will be a volume of a square or of a rectangle or cube or something like that. Okay, so they will not combine two or three of those types into one. Okay, so that you don't need to worry about. Okay, so let us just get to the next one, and this should have been nearly part of. Let me just move it. It should have been part of those ones for conversions. So nearly important with the conversions is that the first thing that I will do with conversions is to first look at, okay, so all of them is or it's to the power of 2 or to the power of 3. So that tells me that there's something different happening here, and this I should actually have added cubic, and let me just say we need to add cubic and to the power 2 conversions, because it's not the same than just divide by 10. Okay, so when we look at this, the 10,000, what I would have done is to say, okay, 10,000 millimeters to the power of 2, so that is actually 100 times 100. If I look at it from just a millimeters point of view. So 100 millimeters is 10 centimeters. So it would have been 10 times 10, which gives us 100. Okay, so what we will need to do here is nearly to say, what is the square root of that? To get it to do a centimeters one. So I will change this for you guys, or just add it later on, so that we just get the right way of simplifying it. Okay, so a bit different, and I think that is why it's important, and it will nearly be the same for all of these, is that, again, when we move that to that, we are actually gonna need to drop, here we drop 2 zeros. Here we need to drop 3 because it is to the power of 3. So 555,000 centimeters will be 555 meters to the power of 3. Here again, move to there. So it needs to move by 100. So it will be 560. So it's just not a 10, it is 10 to the power of 2. So 5,6, we have moved 1 twice. That is how we will get to the 560. So very important when we work with cubic and to the power of 2. So area and volumes that we need to remember that it was a number that was times 3, and with the 2 it was a number times 2. So very important when we do those conversions. Does it make sense, those type of conversions? You can just really give a thumbs up if it's fine. I will also, yes, Rebecca, do you have a question, or is that to say you're fine? Cool, thanks, Tamlin.
It was.
Yes. Okay, so and that's why I'm looking now for this conversion nearly to make it a bit easier. Um, so that I can just quickly show you again. Um, so that okay, here is a better one. So let me just quickly go out here.
Okay.
And hopefully this will make a bit more sense. So what we'll see here is when we work with a cube, we would normally have. So let me quickly. So if we convert it from centimeters to meters, we would normally say if it was 5 centimeters, or let's put it 500 centimeters, to convert that to meters, we would have said, okay, 500 divided by 100. And that would have given, let me just see, 500 centimeters would have given us 5 meters. Okay, so that is if we just converted centimeters to meters. But now what we have, so centimeters to meters, we would have divided by 100. But now, and let's do it this way, it was only for one of the sides. So now we need to do it for that side as well. So there's another 100 that we're going to divide with, and we need to do it for the other side as well. So there's another 100 that we need to divide with. So where it would have been normally just divide by 100, now it is divide by 100 to the power of 3, because we are working with cube. Okay, so that is nearly the difference between, so when we're working with areas, instead of it now being divided by 100 to the power of 3, if we moved from centimeters to meters, it would have been 100 to the power of 2. Okay, so that's the difference. So perimeter, it was to the power of 1. So that was perimeter. Area would be to the power of 2, and then volume will be to the power of 3. Okay, so basically, because we are changing from a flat unit in the perimeter, now suddenly we've got area, so it is to the power of 2. If we go to volume, it's to the power of 3. Does that make a bit more sense? Cool. Okay, so, and I think this one is very important, because they there will be a one like that in your test, or not, sorry, your test, your assignment, and probably in the exam as well. Just want to the power of 2 is, what do we call that? It's not cube. Just want to get that we get the other one. The other table as well, that we just get the units for you, so that we get the, okay. So just that you have both. So let me take that out. There's the one for you, and here's the other one for you. So that you can see when we need to convert the one, where we convert to, and if we convert the second one. So if it's area conversion, it's 100 to the power of 2. If it is the cubic, it is 100 to the power of 3. So if we convert kilometers to meters, 1,000 to the power of 3, 1,000 to the power of 2. If we convert meters to centimeters, 100 to the power of 3, 100 to the power of 2. And if we convert centimeters to millimeters, 10 to the power and 10 to the power of 2. And obviously then the inverse, if we don't divide, but we need to multiply, exactly the same principle follows. Okay, so I think that will also help you when you need to sit with some of the assignments, when you have this with you on hand as well. Okay, so that was study unit 4 on measurement. So then we go into the last few slides, and this is basically what we need to look at. Is first we look at the definition of expressions, equations, and formulas, if they really would ask this in a assignment, it might be for a definition kind of question. I have seen that they do things like that. So then you have the definition, but basically an expression is where you just say something. So it is a 3x plus a 7y. You don't say equal to, that is just your expression. So expression can also be 5x to the power of 3 or to the power of 2 minus 3. That can be an expression. When it becomes an equation is that extra part that is needed for it to become an equation is when you say it's equal to something. So that part was the expression, but if you add the equal to something, then it becomes an equation. And formulas is it's things that normally is already known. So the formula like E equals mc squared, that's a formula. This was a formula. So it's something that is already known. We know the formula for volume is this. So that is a formula. What we would most likely do with in this study unit is solve equations, because we've worked out to solve formulas, formula of volume, formula of area that we can do. They can ask you to write the expression, so they can ask you to say, write the expression of if X is apples, Y is lemons, write it as an expression if you have 3 lemons and 5 apples or something like that. So that is something that they can ask in an expression, but then it will be nearly like a word sum. So let's look at these two first. We look at it if it is an expression, if it is equation that you need to solve, or if it is something else that you need to do. So C-Sway wants to lay carpets on the bedroom floor. The carpet tiles are 500 millimeter by 500 millimeter each. So let's just, so 500 by 500. The room measurements are 3,6 meter, 3,5, sorry, by 6 meters. So let's say that's 6 meters. That is 3.5. So that is nearly the room measurements. Okay, so if the tiles interlock with each other, determine how many carpet tiles are needed to cover the floor. So if that now is the tiles that needs to go in there, how many tiles do you need to cover the floor? So that is basically what they are asking. So this one is a bit different because here you will have an area, there you have a small area. So, and here we say, look at that, 500 millimeters, and we go to meters. So that is, I thought there would be at some point a catch like that. So to get the area of one of these tiles, we would say 0.5 meters. times 0.5 meters, which is 0.25 meters to the power of 2, but that's fine for now. So one of the tiles is 0.25. So how many tiles do we need to fill this whole area? That whole area is 6 times 3.5. So how many tiles do we need to fill the area of 21 square meters? Okay, so what we actually have done here is by giving us a word sum, we created an equation to solve for x. So how many tiles do we need? 21 divided by the 0.25, which is then equal to 84 tiles. Okay, so basically 84 of these tiles will fit into this total area. So what we've been given is the small area of a tile. They've told us you need to calculate the area of a big room, and then how many tiles will fit into that big room. Okay, so by giving us this word sum, we needed to work out an equation so that we could solve the question. Okay, so this is, they like to ask these type of questions to you guys, where they love to ask for word sums, so that you need to put the word sum into an equation and then work it out. Okay, so let's look at the second one as well. So when he wants to paint a lounge, the lounge measurements are as follows. The height of the walls is 2.5 meters. Two walls are 5.4 meters long. Okay, so that's the height of a one wall, or 2.5 is the height, 5.4. They say there's two of them, plus the others are, again, the height is 2.5, but it is 7.2 meters long. Okay, and there's two of them as well. Okay, so the first one, need to calculate that area. So 2.5 times 5.4. And let me just clear my calculator. 2.5 times 5.4 is 13.5 times 2 will give me 27. So the area to cover those two are 27. Let me write it at the top. Just if we need to work out something else. The area for this one is, again, 2.5 times 7.2 gives us 18. 18 times 2 is 56. Okay, so 7.2 times 2.5 times 2 gives us 56. Okay, so that is all the walls. So let's see what they are also telling. One of the 7.2 meter walls has a sliding door of, okay, one of them has a sliding door of 2.2 by 2.2. Okay, so we will need to subtract that. So 2.2 times 2.2 is 4, let me just put the 2.2 in here so that I can write above it. So this is quite a interesting and long question. So 2.2 times 2.2 is equal to 4,84. So remember plus, minus. And when we say Winnie can cover 5 square meters with 1 liter paint, determine how many liters of paint are needed. Okay, so let's first work out how much that was. So 27 plus 36 is 63 minus 4.84. So she needs to cover 58.16. I say she can cover 5 meters, so per 1 liter. So 58.16 divided by 4 will tell us how many liters she needs. So she needs 11.63. You can't work with a 6 3, so round it to the nearest liter. So she needs 12 liters of paint to cover that area. Okay, so it is a bit different type of question, but again, it feels a bit easier if one draw it for yourself to see what you need to do, because when it's easier to see. Okay, well, if it's that is for one side, so times 2, that's for other sides times 2, and yes, there's a sliding door, which makes sense. So I get a total area if I divide it by how many paint per liter, you get your total paint. Okay, so again, a word sum. So this is merely a combination of area with equation. Okay, so because you now needed to every time use it in an equation to get your final answer. Then there's also equations like this, so which I like much more than to work with word sum. So equation like this, what I normally would do again is I want all my x's on the one side, all my numbers on the other side, so that needs to go to that side. So to get rid of it, I need to add on both sides by 3, then that will disappear, but then on this side it is 2 plus 3, which will give me x equal to 5. Okay, so that is an equation that we can be asked to solve. The same in this instance. I don't want to take it to that side for 3 because I want it to be positive. So I'll rather take the a to this side, then it becomes negative. So on this side, it is 3a minus a, which will give me 2a. If I move the 8 to the other side, it is 4 plus 8. So 4 plus 8 is 12. So if I then calculate a, it is 12 divided by 2, which is 6. If I did it the other way around, if I said, okay, let's move a 3a to that side, it would have become minus, so minus 3a plus a. On the other side, that minus 8, I would have taken the 4 across. So the positive 4 would have become a negative 4. So it would have become negative 12. So negative 2a would have been negative 12. Then it is a would have been minus 12 divided by minus 2, which would have given us also 6. Okay, so answer is still the same, but you add an extra step into that. So I like to keep always my variables where it is positive so that I don't make errors when we look at the negative sign. Okay, then what they can also ask you is to change the equation or change the subject of the equation. So, but they need again to tell you, okay, B is my subject. So if B is my subject, I keep B on this side and I move just everything to the other side. So the 5 stays there. I need to move that to the other side. So a becomes a minus a on the other side. The minus c becomes a positive c on the other side. So that is all that you do. So if I say change the subject of the equation, they need to tell you to what you need to change it. So on this side, if we need to change it to y, so let's first keep it as 4y. Then we take the 2x to that side, so it becomes minus 2x plus 8, which is the same. Now we still need to get rid of that 4. So then it becomes divide, so 2x divide by 4, and 8 divided by 4 is 2. Okay, so then we have y as the subject, and all the others move to the other side. The same when we had b. If there was a 2 in front, we would have needed to cancel out the 2's, but then we would have divided everything by 2. But not needed because there wasn't something. Sure. Okay, that was quite a lot in this session. I think at least we have caught up to what you guys need to do for Friday's assignment. So we will be on time with the next one also to be able to cover that for what you need in your next assignment after the one that's due for Friday. Okay, does that make a bit more sense? Did this session help? And then I will post the presentation onto our WhatsApp group. I will, after I've loaded the recording, I will post the recording onto our WhatsApp group as well. So Tamlin, you are on the WhatsApp group, I hope. If you're not, you can join. So if you're not on the WhatsApp group, please send me a WhatsApp on 0837908387. Okay, cool. Perfect. Great. So I will post everything again on the group so that you guys can go through it again and see what, if something that you missed, you can, and then please ask. So if there's something that's not clear, ask on the group. we're only a few, so please ask. It's not the issue. So if there's something that you struggle with, please ask, and I can make a quick video or show something on paper or something like that as well. Okay, so that is it for tonight. Have a good evening. And then I'll share everything with you guys. Hey, cheers, everyone.